Okay, so today we're going over the standard operating procedures of graphing, the SOPs, the do's and don'ts of graphing parabolas. So far we have learned different functions, and we should start to recognize the different functions. We should know that if something is squared, it's going to give you a parabola. It's a little shaky, and so this would be a parabola pointing up. Here we recognize that it's a linear equation. It's got that y equals mx plus b flavor, so we know it's going to have a skewed slant with a slope of 3. We know that we have our vertical lines at 2 and our horizontal lines at 4, so we should be able to recognize when we have a vertical and horizontal line. Our absolute values we should recognize are going to give us v's, right? So -1, 0 with very sharp, steep slopes. And we should recognize when we have that little curve, actually that curve is a sideways, half of a sideways parabola. So it's half of a sideways parabola. So those are the things that we should start to recognize for right now. So when you are asked to graph parabolas or graph period, you should always graph using graph paper. It's a must. You have to. So if you have to go purchase it, or if you have to go to modules and print out some graph paper, you cannot make up your own graph paper. So you need to have your graph paper. Most of the time we go by ones. So if you don't label anything, it's assumed that you're going by ones. So if you're going by ones and you want to write on it, you don't have to write 1, 2, 3, 4. It gets kind of squishy. So to save space, we just write on. We just write like every other one. So 1, 2, 3, 4, etc. 1, 2, 3, 4. -1, -2, -3, -4. Notice I'm not writing in the boxes. I'm not writing in the boxes. I'm writing on top of the line. So you want to make sure that when you're writing it on top of the lines. So so that's important. Sometimes you have to go by halves. So if you went by halves, then this would be obviously be 1, and that would be 2, because in here would be 1/2. This would be, 1.5, etc. So you can go by halves when you have numbers small enough that you need to do that. You can go by 5s, but generally speaking, you really should either be going by 1s, 1/2s when you have a really fat parabola and you need to, or by 2s. You really shouldn't need to go by 5s. You could go by 1s on the x-axis and then maybe go by 2s on the y-axis. I mean, that's something you could do, but usually we use the same increments for both axes, but you technically could do that. So most of the time, please go by 1s. One of the things that we don't like, and it just bugs teachers, is when you guys use a piece of graph paper and you add all those extra tick marks. You're kind of losing the whole reason why you're using graph paper. The lines are there for accuracy. So when you add those little extra tick marks, you're not adding the accuracy of your graphing. So it's not acceptable to start adding a bunch of tick marks in between the lines that you were given. That's why we have the different increments. That's the whole purpose of that. Sometimes you are allowed to adjust your x's and y-axis when you think it's necessary. So when you're looking at your t-tables and your graphing, you might realize, oh, this particular graph is shifted up 3 and it's opening up. So when I build my axis, I may want to decide to lower my x-axis really, really low, because I know my parabola is sitting way up here in this quadrant, and that gives me more room up there. So that's something that students didn't realize you could do. Sometimes, what if the parabola was shifted to the right more? So I might want to take my y-axis and move my y-axis way over to the left, because I know my parabola is way over here, more to the right, and so I want to give it more room. So your parabola, your coordinate plane doesn't have to be centered. You're allowed to move your x and y axes when you think you need to move that. We're working with, in this chapter, we're in chapter 2, and we're working with quadratic functions. Quadratics are polynomials of degree 2. That means where the exponent, the highest exponent, is 2. So numbers 1, 2, 3, and 4 are all examples of quadratics because they have a degree 2, right? The exponent is 2. And you might look at number 4 and go, wait a minute, that doesn't have a squared in it. But then I ask you to think about the format of that function and think about, is it really a quadratic? I wonder what that would be. And then these are the not acceptable parabolas. So parabolas parabolas are not V's. So you should never have a V for a parabola. So it's unacceptable. Parabolas are never flat, where all of a sudden they're flat down here at the bottom. They also don't have where they have a nice like U-shaped here, and then kids will go straight up, and then they'll go straight like they're parallel lines. That's unacceptable, to have that kind of parallel lines, to have that flat little bottom. I call this one the tulip because they have like these little branches that kind of hook out. This one I call the half breeds because we have half of an absolute value and half of a parabola. And then we've got our little squiggly where we're just kind of like all over the place, right? So our parabola should be nice and should look like a nice parabola with symmetry. So those are the unacceptable parabolas. There's a difference between a sketch and a graph. Sometimes it's appropriate to give us a sketch where you're saying, oh, it's just shifting it up 3. Okay, I'll just move it up 3 and then I'll just slap a little U shape in there. And on the homework that we're going to be doing coming up, we want you to graph. So how do you know? Well, if it says graph. If it says graph, you need to be more precise. And then we'll talk about sketching later. So when you're graphing, you need to have a t-table, and the t-table work needs to be near the graph. We don't want the t-table to be on a separate piece of paper because we want to see your work that goes with that graph. So that's important. So for an example, we have this parent graph, right, of a parabola, and we just shifted up 3. So wouldn't the vertex be 0, 3? And then if we picked the points, 1, and we plugged in 1 for x, that would give us 1 squared plus 3. That's 1 plus 3 is 4. And then maybe we pick 2 and we do 2 squared plus 3. That's 4 plus 3. That's 7. And then maybe we pick 3 to plug in to the function. Right? We plug 3 into the function. And so that gives us 9 plus 3 is 12. And we plot the vertex is 0, 3. And we plot 1, 4. And 2, 7. And 3, 12. And if we had another point, if you had another point and your point's way off your graph, you don't have to plot that point. As long as you have enough points that you can see the graph that you're plotting and get the idea of the graph that you're plotting, that's fine. But we really usually want 3 points, 2 to 3 points after the vertex. But if it's way, way, way off your paper, then go ahead and not graph it. And then parabolas have symmetry. So basically there's this line of symmetry that goes through the vertex. And that's like a fold line. So if you were to fold that parabola, these points would land on the other side of that parabola. So this point is 1 away from the fold line. So this one would be 1 away from the fold line. This other one is 2 away from the fold line. So on the other side, if you folded it, it would land 2 away on the other side. And this one's 3 away from the fold line. So this one would be 3 away from the fold line. That because the parabolas have symmetry. And that fold line is called the axis of symmetry. So that fold line is called the axis of symmetry. And they're going to get into more of all of that later. We call it AOS for short, but they're going to talk about graphing in the next few videos. But when you plot your points, then you need to draw a good graph. So like I need to turn mine sideways and maybe use a pencil so I can go and make it have symmetry. So another parabola that's not okay is some students will make a parabola like this and they'll just put arrows like that, right? So that's unacceptable. That's another one in the unacceptable category. It has symmetry, so you need to extend it and make sure that you have that, show that symmetry. So those are the do's and don'ts of graphing parabolas and showing your work next to your graph. Notice how I lowered my axis because I knew that I was going to need quadrant 1 and quadrant 2. I was going to need more of that room, so I took that x-axis and lowered it. So in the next few days, we will be going over graphing parabolas in 3 different forms. We're going to look at graphing in vertex form, we're going to be looking at graphing at standard form, and graphing in intercept form. And that's what the next few days are going to be about. So this is the SOPs, the basics of the do's and don'ts of graphing parabolas.